Okay. All right. So last week, what did we learn?
Confidence intervals.
Confidence intervals. Okay. Confidence intervals, and we are basing the. Well, just tell me what is a confidence interval. And why do we bother making a confidence interval?
It's because you can't measure the entire population.
Mm-hmm.
It's kind of like an estimate or like an approximation based off of the sample.
Okay. And what are we trying to create an estimate of? The mean of the population. Okay. So our population produces a whole bunch of different numbers, right? But we're not interested. I mean, we're probably interested in all the different numbers that the population might produce. But what we're trying to understand is where is the mean? Okay. So, if we looked at the United States and we said, what's the average age? Okay. What is the average age of someone in the United States? Okay. So people in the United States can range anywhere from 0 days old, or maybe one. I don't know. I guess if they're just born, they're 0 days old, right? To I don't know. Oldest person is 115. I don't know, 100 something. Whatever. However old the oldest person is. Okay. So there's a whole bunch of different ranges. Most people are probably in between. Or a lot of people are going to be in between like age 10 and age 50 or something like that. And but then a lot of people are over 50, a lot of people are under age 10. And we just want to know, what is the average age? At what point are you really, quote, over the hill and you're, over the mean age or over the median, whatever you want to say. So we create a confidence interval for the mean, okay, which is the population mean. And that might be, I'm 90% confident that the mean age is, actually I have no idea. What is the mean age of an American? Does anyone have any idea? I have no idea either. I have no idea. Okay, so let's say it's between 35 and 43, okay? Let's say I'm 95% confident that the mean age is between 35 and 43, okay? This interval is just our idea of where that population mean is. And it doesn't say, if I pick a random person, it says nothing about what this random person's age is going to be, okay? Or even if I take another sample of 100 people or something, it doesn't say anything about that particular sample. It's just about the mean. So let's just review a few things about confidence. Okay. So we create an interval. And this interval of plausible population parameter. Okay. And in our case, the parameter of interest is the population mean. Okay. If you take another statistics class or maybe the next level of statistics, you'll create confidence intervals for the population standard deviation, population whatever else, okay? Other parameters of the population. Okay, so if our 95% confidence interval is from 35 to, I don't know whatever I said, 43 years, again, it's a statement of confidence. It's not, it is not correct to say there's a probability. Not say mu, the population mean. Okay, so why is this statement wrong?
It's not probability.
Yeah, the population mean, mu, okay, is set at some number, okay? We don't know what it is, but it's not, there's no uncertainty about it, okay? It's not subject to our notions of uncertainty. It's already set. So it doesn't make sense to talk about a probability about something that's already determined. Right? You don't talk about what's the probability of some event that happened in the past. Okay? The things that have already been set, they're set. Okay? I mean, it can turn into a philosophical debate, but from our notion of probability, then it doesn't make sense to say that. Okay? Also, do not say, there's a 95% probability that another sample So in this case, it is okay to talk about probability because we're talking about another sample that we're going to draw that we don't know anything about. But the interpretation of the confidence interval does not apply to future samples. So this is also wrong. And whether it's another sample or there's 95% of the population is between there and there, this is also wrong. Again, let me ask you. So that's it for the do not says. I'm sure there's a whole bunch of other things not to say, but these are probably maybe the most common misinterpretations of a confidence interval. Yeah, we just say we are 95% confident. This is correct. The correct thing to say is we are 95% confident that the population mean mu is between 35. Oh, I guess another common mistake is that somebody might say we're 95% confident that instead of mu they put in y bar, the sample mean is between 35 and 43. Why is that wrong?
Did you know the sample mean?
Yeah, because we know the sample mean. Again, we've already drawn a sample. The sample mean is known to us, so it doesn't make sense, right? If we created a mean from confidence interval from 35 to 43, that means probably our sample mean was 39. And so we already know that the sample mean is this value. It doesn't make sense to say we're confident about that. Okay? We're talking about the population mean, which is unknown to us. Can mu be outside of this interval? Okay. Yes. And what does it mean if the population mean is actually outside of our confidence interval? What does that mean? Yeah, it just means our sample was unusual. Okay, our sample was unusual. This can happen. Okay. It would be, it would be surprising, maybe. And it just means that our sample was unusual. Okay. Unusual with respect to our understanding of the sampling distribution. Is that good with everyone?
Mm-hmm.
Okay. So, a confidence interval for mu looks like what? How do we, what is this, I guess the formula that we make for confidence interval? We put our sample mean y bar, that goes in the middle, and we go plus or minus our margin of error. And so what is how do we get our margin of error? T, okay, some critical value T times the standard error. Okay, the standard error was S over the square root of n. So maybe I'll just do that, S over the square root of n. Okay. Let me rewrite this and just say y bar is the estimate of mu, and plus or minus, this is a critical value from, and this over here is our standard error. We're gonna make confidence intervals for two samples now, okay? Or based off of two samples. And at first it might look a little bit complicated and a little strange, but really it just follows this exact same form here, okay? It's just maybe our letters, we add a few letters here, okay? Alright, so let me tell you where we are headed. Okay, let's say we wanted to compare two groups. Okay. And what if we said, anytime you compare two groups, you're always going to have individuals that might stand out or buck the trend. But overall, we want to just say, is the average of this group different from the average of this group? That's what we want to ask. Okay. Is the mean of, group 1 different from the mean of group 2?
You mean
Okay.
is?
Did I write? Oh, if is. Thank you. Is the mean of group 1 different from the mean of group 2? Okay? So there are, we can ask tons of questions, okay? So, classic. The most boring example would be, why do I keep wanting to write it? Is the average height of males different from the average height of females? Okay. We don't need statistics to answer this question, but we can use statistics to confirm what we already know. And the answer to this is what? Yes. Okay. The average height of males in general, or no, the average height of males is higher than the average height of females. Okay. Why? I don't know why, but that's how it is. Okay. Now, of course, if you were just talking about individuals, we might find a woman who's tall and a man who's short. Okay. But in general, if we looked at the average height of all men and the average height of all women, the average height of men would be higher than the average height of women. Okay. But we can. This can be applied to anything else. Is the average IQ of males different from the average IQ of females? Is the average miles per gallon of this brand of car different from the average miles per gallon of this other brand? Okay. Is the amount of money spent by a consumer after seeing this commercial different from the amount of money spent by a consumer if they never saw the commercial? Okay. There's all sorts of things we can ask, and the only I guess the requirement is that the thing that we are talking about has an average, or that we can calculate a mean for it. Okay. So this limits us to numeric variables. Okay. So in essence, we are comparing the means of two groups. No question. I don't know why I'm putting all these wrong things on the board today. Okay, we're comparing the means of two groups. Okay, so it requires numeric variables. Okay. Requires a numeric response. And the fact that there's two groups implies that there's a categorical variable that distinguishes one group from the other, right? Okay. Separated. By a categorical variable. Group 1 versus group 2. Let's see. Alright, let's try an example here. Let me use this top board. Okay, let's say we take a sample of, let's say, n equals 10 men. And let's say the average height of these 10 men is 69 inches, and the standard deviation is 3 inches. Okay. And then we take a sample of, let's say, 12 women. The average height here would say is 64 inches, and standard deviation 3 inches. So we could create a confidence interval for the mean height of men and the mean height of women. This might not be a good example. Let's try it though. Okay. I'm going to go y bar plus or minus t times s over the square root of n. So if I have n equals 10, what is the, if I'm going to make a 95% confidence interval, what would I use here? I would go 69 plus or minus, it's going to be too small, 2.262 times 3 over square root of 10. Let me change this from 12 women to 7. I don't know if that's going to help. We might not be, it's still might help. Okay. And over here, I would have 64 plus or minus 2.447 times 3 over the square root of 10. I'm going to get a difference.
It's not 3 over square root of 7.
Oh, I'm sorry, square root of 7. Thank you. So I'm not paying attention. Okay. So I get 69 plus or minus 2.15. So close. The numbers I used for my example were just a little bit off. I wanted there to be just a tiny bit of overlap here, okay? So I could fudge these numbers a little bit.
I have a question.
Yes.
So I didn't hear you say that we wanted to make a confidence interval of 95%.
Yeah.
But normally is that the standard,
yeah,
or?
I guess 95% is kind of our default go-to. For some reason, that's our favorite confidence level. But yeah, maybe you'll see something for 90% or 99%. Okay. This is also 95%. Okay. Well, if I made a 99% confidence interval, it would be a little bit wider, things like that. Okay. If let me just fudge these numbers a tiny bit, okay? So let's say let's say I used only 9 here or something. Okay. Okay, so then I'll get 2 over the square root of 9, and then so I'd be 69 plus or minus 2.26. So then I would get 66 point.
Are you not changing your T?
Oh, it does change also.
2.306.
2.30?
3, yeah.
306? Okay, so this would just become plus or minus 2.31. Okay, so now I get 66.69 and 71.31. Okay, so if I were to draw a number line of plausible values, plausible values for the mean mu. Okay, so for men it would go from 66.69, which is right around here, to 71.31, which is right around here. Okay, this is my 95% confidence interval for mean height of men. Okay, is that alright? And then I'm going to draw one for the mean height of women, which goes from 61.23 over to 66.77. Okay. So there's just a tiny bit of overlap here. So what does that mean? If I said, does this provide evidence that the mean height of men and the mean height of women are different, what would you say? Okay, so let's just back this up. So look at, this is the confidence interval for the mean height of women. Does this provide evidence that the mean height of women is not 70 inches?
Yes.
Yes, okay, because 70 inches is not in here. Does this provide evidence that the mean height of women is not 66.7 inches? No. No, okay, because 66.7 is in here. Does this provide evidence that the mean height of men is not 66.7 inches?
No.
No. So there is some tiny sliver of possibility that the average height of men is 66.7 and the average height of women is 66.7. Okay. And in the beginning, people thought this was how we should do the comparisons, and they would they would always be running into this problem and be like, well, that doesn't quite seem right, but I didn't collect enough data, and so I'm kind of stuck in this situation where now I don't feel like I can say that men are taller than women on average, and that's what I wanted to do. Well, so it turns out that we shouldn't go about saying, here's this tiny little bit of overlap. And so we don't have evidence that men and women are the same, have different average heights. Okay? Because for that to be the case, right, it would have to be like the average height of men is at 66.7 inches, and the average height of women would have to be 66.7 inches, okay? And so there's this kind of like not the universe, but when we collected data, it had to align just perfectly right, where when we took our average sample of men, the average happened to be too high, and then when we took our sample of women, the average happened to be too low. Okay, that would be the only way for the mean height of men and the mean height of women to have the same average height and yet produce two different samples that were this different. Does that make sense? So the only way we could have gotten a sample of men where the average was 69 and the sample of women where the average was 64, if they indeed had the same height, would be, this is the average, and our sample happened to produce men that were too high and women that were too low. Okay. Because of that strange because we're counting on that actually, people said, wait a second, that's like too much of a coincidence for us to be hoping for. Let's just kind of assume that there was no real relationship. Or, if we said there's no relationship between the sample of men and the sample of women that we picked, can't we rule out this highly improbabilistic circumstance? Okay, does that make sense? Kind of, maybe. Well, anyway, after studying it a little bit more, they realized that we have to look at the standard errors of the two groups together. Okay, we're going to come up with a standard error for the quantity y1 bar minus y2 bar. Okay, so if we looked at the average of group 1 and the average of group 2, and we took the difference between them, let's make a standard error for this difference. Not the individual means of the groups, but the difference between the means. And it turns out that we can look at the standard error of group 1 and the standard error of the mean of group 2 as if they were kind of orthogonal, that they had no relation to each other. Okay, and this would produce a standard error for their difference. Okay. So what was the standard error of y1? That would be the standard deviation of group 1 over the square root of n for group 1. Okay. And what's the standard error for group 2? That's 2 over the square root of n, go for group 2. Okay. So then a squared plus b squared equals c squared, right? So I do this thing squared plus this thing squared is equal to the standard error of 1 bar minus 1 bar 180 squared. And so, just taking the square root of multiplying everything out, this becomes standard error of the difference Let me get that. This is my standard error. Okay, so then let's talk about making a confidence interval. Okay, so this is going to be the standard error of the group difference. Okay. So let's so we want to make a confidence interval, and this time we're making a confidence interval for the difference between two group means. Okay. So we want to know, we're not asking what's the average height of men and what's the average height of women. Okay. We're asking what is the difference between the average height of men and the average height of women. Okay. And so that answer, what would a plausible answer for that difference be? I just want to make sure we understand this concept here. Okay. We're not asking what is the average height of men, which is around 70 inches or something, and the average height of women to be around 64, 65 inches. We're asking what is the difference between the average height of men and the average height of women.
6 inches?
So yeah, 6 inches would be a plausible value. Okay, that's saying the average man is about 6 inches taller than the average woman. Okay, so 6 inches would be a plausible value. Okay, all right. So if we want to make a confidence interval, what are we going to put in the middle of our interval? Okay, so over here, when we made a confidence interval from u, we put y bar in the middle. What do you think we'll put in the middle here? Well, I'll tell you, it's our estimate of mu1 bar, or mu1 minus mu2. So that would be, so in the center, I'm going to put y1 bar minus y2 bar. This is my estimate of the true difference, which is based on my sample. I'm just taking the difference between these sample averages. And then I'm going to go plus or minus some t star, some critical value t. Times my standard error, which is this thing. Okay? That's it. Okay, and this is the confidence interval that we have for a difference between mu1 and mu2. We'll go back and we'll make another thing. Okay, so we know about t star. About selecting. Okay, so just like before, you would use the confidence interval or confidence level that you want, and you'd go up that column. Okay. the question is, how many degrees of freedom do I have? Okay. Now it used to be n minus 1. But now I've got two n's. I've got an n for group 1 and an n for group 2. Okay? So we've got different, the truth is there is a way to find the degrees of freedom, but the true method is very complicated, and we don't want to do it by hand. Okay? So with a computer we can find it easily, but to do it by hand it's kind of tedious. Okay? So too tedious to do by hand. You can see it in the book. It's on page 206.
I thought that the degree of freedom was n minus 1.
It's n minus 1 when it was a confidence interval from mu, when we only had one sample and we only had one n. Okay? Over here we have two n's, right? We have group 1's n and group 2's n. Okay? So yeah, the true degrees of freedom, yeah, is on page 206. It's kind of this pain in the butt that we don't want to deal with. So so different textbooks will say different things about how to estimate the degrees of freedom. Okay? There's kind of I guess the safe bet df. Okay? So the df will be anything between, and then there's kind of like the I don't know, a little bit slightly riskier df. Okay? Not really. Okay? So one approximation is to use n1 plus n2 minus 2. Okay? This is kind of the upper limit. So it's just basically n1 minus 1 plus n2 minus 1, and you add those two together. Okay? So this is the upper limit, and this is what I prefer. Okay? This is what we'll use. Use as an approximation. But if you take another stats class, they might tell you something else. Okay? They might say use df is equal to n minus 1 using whichever n is smaller. Okay, this is another method. And the true number of degrees of freedom is usually somewhere in between there. Okay. If n1 and n2 are similar in size and have similar standard deviations, it will be closer to this one. If they're drastically different, then it'll be closer to that one.
Wait, say that last thing again. Sorry. Say that what you just said.
What I just said? So if the sizes of the two groups, of the two samples, like you took 10 men and 10 women, okay, and they have similar standard deviations, okay, the true degrees of freedom will be closer to this approximation. Okay? But if you have two different groups, like 10 men and 200 women, and the standard deviations are drastically different, okay, then the true degrees of freedom will be probably closer to this one. But it doesn't really matter. Okay? These are both approximations. And so when you use a computer and it gives you a degrees of freedom and that's like 3.7, just use that. Okay, that's going to be the finding it using the actual method. Okay, so let's make a confidence interval here, and we'll say we'll go back to our example. Group 1 was what did I say? 9 men.
Yeah.
With y bar equal to 69 and standard deviation equal to 3. And the group 2 was, I forget, 7 women
Yeah.
Okay, so make a, go ahead and take a moment and make a 95% confidence interval for mu1 minus mu2. Something around here. Okay, so what do you guys got? You guys still working? Okay, so you guys are still working, that's okay. I'm just plugging in straight across, 69 minus 64. This is my estimate for the difference in the average height of men and women, okay? So based on the samples that I took, where I got an average height of men being 69 inches and the average height of women being 64 inches, my best guess for what's the difference between the average height of men and women is around 5 inches, okay? Then I'm going to go plus or minus my t star value. So here I have a total total of 16, n1 plus n2 minus 2, so 16 minus 2, 14 degrees of freedom, and 95% confidence. That gives me 2.145. And I'm going to multiply that by my standard error, which is going to be 3 squared over 9 plus 3 squared over 7. Right? And if I did my calculations right, I get 5 plus or minus 3.24.
I got,
2
Yes,
point.
I got-
You got something different than me?
I got 3.033.
Okay.
What?
You used
Are all of your numbers the same
You did
as
the
mine
same
here?
yeah.
Let me
You
check.
used minus
I
37.
got the
I
same.
Oh,
thought-
I
I
did.
That's
thought
what I
with
did.
you
You're
Yeah.
right.
That's what I did. What?
If you use 9 rather than 7.
Yeah. That's
Yeah,
what I did.
yeah, so make sure you use n1 and n2. I make mistakes like that all the time too. So just pay attention, right?
And then that's the answer. 1.76 to 8.24. That's it.
Okay, so my 95% confidence interval is from 1.76 to 8.24 inches. Okay. So what does this say? I'm 95% confident that what?
The difference between
95% confident. So let's, I'm going to change the wording. So I could say I'm 95% confident that the difference between the average height of men and women is between 1.76 and 8.24 inches. Okay? That's fine. It's a little bit tough to interpret. Okay? So I'm going to just change up maybe the order here, and I'm going to say the exact same thing, just in a way that's a little bit, I think, easier to digest. Okay, so I'm going to say I'm 95% confident that the average height of men is between 1.76 and 8.24 inches taller or higher than the average height of women. Okay. I don't know if that's any easier to understand. In my mind it is. But... Okay, so does this provide evidence that the average height of men is higher than the average height of women?
Yes.
yes.
Yes. Yes. Okay. Because it goes from 1.76 to 8.24. What would be different if this were not to provide evidence? Okay. What would our interval look like if it wasn't going to give us evidence that there was a difference?
Smaller.
Yeah, it would include the number 0. If 0 were in the interval, then we would not have evidence of a difference between the means. Okay, because 0 would be a plausible value. Okay. So in this case, because 0 is not in the interval, is not within the interval, we do not have evidence that, I'm sorry, we do have evidence, I'm sorry. Because 0 is not in the interval, we do have evidence that there is a difference between the average height of men and the average height of women. Okay. And in this case, we have evidence that men are taller. Okay. course, again, if we were to draw individuals out or something like that, we might not. The woman might be taller than the man, but this is not about individuals. It's about the group averages or the population averages. Okay. All right, and then so the converse or the inverse, contrapositive, I don't know. It would be is also true. Okay, if 0 were in the interval, then we would not have evidence that the average height of men and is different from the average height of women. Okay, let's take a little break there, and then we'll come back. We'll finish this topic and.